angles and rotation. That's what we're heading to, and the whole course waiting ahead for you guys. It's all about angles and rotation. Okay. See? So anytime you think of it, think of an angle, and the way we learn that from since the days we were kids is the same way. You got two rays, right? You got two rays, and an angle is just basically representing how much opening up between the two rays you get, right? Two rays starting out from one common vertex. See what I'm saying? No? And then we got two rays shooting out, and then how much open out? That's the angle between them. See what I mean? Like how much opening up, right? And so the idea, but now when we get to pre-calculus 2, then it's going to have to become a little more specific, and we've got to go a little more precise here, a lot more advanced than what we're learning back in the days we were kids. So now you got two rays, right? Let's say for now I'm going to call one ray right here is the initial. And one ray is called initial side. So for that reason, it's also a terminology for everyone. So I'll just write it in red ink right here. So think about that. You got initial side. We pick one ray, we call it initial side, right? And then the other ray, think about the idea of the initial side that it stays fixed. Okay? Once you put it on the picture, it stays fixed. But then the other side, the other ray is going to keep opening up, rotating away from that initial side. See what I mean? Right? And so the other side right here that's rotating away, that's why you see that arrow right there. It's indicating that we have a rotation, we're rotating that other side away. And that other side right there, we call that as the terminal side. Alright, we look at that then. The terminal side. So the idea now is that the terminal side is rotating away from the initial side, that's why we're producing angle in between. And so, and yes, that's how we call that. And so in that way, you can see right now I'm drawing the arrow that's indicating the rotation. I'm going counterclockwise, right? So, but we'll get into that even a little more. But now, initial side and terminal side, there are so many different ways how you can put. Sometimes your initial side goes down this way, and then from there you have a terminal side opening up, right? See what I mean? Okay. And then sometimes you have your initial side going like this, and then your terminal side is opening away. But see, these are all in a counterclockwise rotation. Okay, so a rotation produces the angle. See what I'm saying? The rotation of the terminal side, right, produces the angle from the initial side of that. And yes, there's initial side, there's terminal side, initial side, terminal side. But now things can become all over if we don't set out for ourselves a rule. And so in that way, mathematicians come up with something like this. When we put things on the axes of the system, right, the x and the y, anytime that we put our initial side right on the positive x-axis, okay, and then left the terminal side being the rotating one, rotating away. See what I'm saying now? Okay, so an angle like that, we refer to. So I'm talking about the way how we position our angle like that, right? So an angle like that is called. This angle is in standard position. See what I mean? So anytime the initial side is perfectly aligned with the x-axis, the positive x-axis, right? That angle is set to be in standard position. So these earlier pictures I've drawn, they're not in standard position yet. Okay. So to make it easy for the rest of the quarter and for the rest of your learning in mathematics, a lot of time, a big majority of time, we're talking about, we're going to refer to angles in standard position. Right? We put the initial side on the x-axis, right? On the positive x-axis, we let the angle rotation, the terminal sides are rotating away from that positive x-axis. See what I'm saying now? So there are not too many times that we're working with something like this. I'm not saying that there's absolutely no times, right? But there's not too many times we're working with an angle in that non-standard position like that, or like these cases. Most of the time we say with that. See what I mean? But yes, at this point right here, you can put down a one observation right here that a rotation, right? The rotation produces an angle. We're rotating that terminal side away from the initial side, it produces an angle. Yeah?
Does it always have to be counterclockwise?
It doesn't, and we'll get to that. Right? So just for easy the starting, we stay with the counterclockwise, and as a matter of fact, I'm about to get there. It doesn't always have to be counterclockwise, right? So now just simply see, that's why I'm saying only any rotation, right? So right now we work mostly with the positive, the counterclockwise. And oops, I'm actually using that term already. So yes, as you're asking that, we're getting into that idea right there. So now in standard position, right? In standard position, you got your initial side here, right? And then your terminal side is an opening rotation being in a counterclockwise. And so an angle like that, we refer to that as the positive. So it's just now a convention. This is a positive rotation, of course, right? Positive rotation. And so, or a counterclockwise rotation as well. But then the angle here is also referred to as a positive angle. See what I mean? Okay. And then similarly, so now to answer your real good question, do we always have to rotate counterclockwise? No. From your standard, from your initial side here, you can rotate your terminal side in this way right here. See what I mean? Okay. The rotation can go clockwise as well, right? It all depends on whatever needs that we're doing. And so in that way, this rotation is, yes, we call it as a negative rotation, right? And negative rotation lead to, more importantly, the negative angle. See what I mean? See, this right there is a negative angle. The positive angle goes here. That's how it is. Easy enough to understand? So now, when we were little and learning about geometry and angles, we were not introduced too often to this. But now when we're a little more advanced, think about it. I refer to an angle as something that came out from a rotation, right? So think about it. You got, let's just for now say you go in counterclockwise, a positive rotation, for example. Your initial side is here, your terminal side is rotating. So if you make one complete rotation, see what I mean? You make one complete rotation, and don't you learn from earlier? And it's not like things that you have to wait till now to know. 360 degrees, right? We use degrees to measure the rotation, right? And how much angle we produce. See what I'm saying up? How much opening up, right? So we use degrees. And so a little more precisely, think about it. We never formulated this until now. One complete rotation, right? One complete rotation. Equals 360 degrees if you measure the rotation in terms of degrees. See what I mean? Right. And I'm talking about the absolute physical rotation right there. Doesn't matter right here. I'm not too worried about the direction of the rotation. Just anytime that you go, see, if you go in the negative direction, you go one complete rotation in that negative direction, you're still going to reach 360 degrees, right? But then yes, you may call that negative, indicating it's the direction of the rotation. So, one complete rotation equals 360. So now think about it. Sometimes you learn prior to getting to this class, sometimes you talk about an angle that's, say, in standard positions and in a positive direction. An angle is like, let's say and I'm not steering out, so forgive me on that, but let's say an angle here is labeled as a 30 degree, a positive 30 degree. That means what? You see? That means we have rotated only as a fraction of the complete rotation. See what I'm saying now? Okay, so a 30 degree is just like one fraction, right? Of a complete rotation. See what I'm saying now? Because hey, a complete rotation, we nailed down that rule, that relationship. It's a 360 degrees rotation, right? And so an angle, any angle that you should know, right? It's basically a fraction of a complete rotation. So now either in positive direction or, see, we already talked about negative direction, and so we can also have some angle, right? Opening down this way, and sometimes people refer to that as negative 45 degrees. See what I mean? Okay? See, but it's a, as far as the rotation, it's a one fraction, right? It's a one fraction of a complete rotation. You know what I'm saying? That? Right. So what fraction is that? The 30 degrees here is, think about it, the 30 out of 360, right? You know what I mean? Right. So it's a 1/12 of the whole rotation. You know what I mean? That's just optional for you guys to understand that. And then the rotation, the angle is a negative angle. Okay? But then as far as the fraction, see, you can go to 45 degrees, right? It's just the 45 degrees over the 360 right there. See what I'm saying now? Okay. That is what fraction is that? It's going to be a 1/8 of that, right? 1/8 of a complete rotation, right? After you reduce the fraction. Yeah. I should have put the negative sign here, and then rotation is also a negative 360. Make it a little more consistent, even though in the way how I see that. You shouldn't even have to worry about that. And that's why now, even when you talk about, hey, this angle is only at 1 degree right there, right? 1 degree is a what? It's a 1 out of 360, right? It's a 1 fraction of a quick rotation like that. See what I mean? And most of the time now, I'm staying with the standard position. I'm sitting right in the standard position. Okay, so there's always a reason why you learn about the equations of a circle. So now we can even apply that into our understanding about angles here. Okay, so let me bring in a few circles on scratchwork here. Okay, you guys hopefully will spend about 1 day, a little more than 1 day on this. But is this a circle?
Yes.
Yeah? Yes, I agree. Right? Center. There you go. Radius.
5.
There you go. See what I'm saying now? Get used to it. Is this a circle? Okay. Whoever says circle, now tell me the center and the radius.
0, 0, 4.
Okay. The origin and 4, right? Guys agree? Okay. So is this a circle? That's a little tricky, right? Yes, it is. Yeah, technically it is. It's right at the origin, right? And the radius 0. See what I'm saying? No? It's just one singleton point. It's still a circle. See what I mean? Okay? It's all good, right? Center is at 0, 0. Radius 0. Of course, in elementary geometry, we were very scared of something like this. But for us, now we were a lot more enjoying that. So yes, that is a circle. It's just a circle that shrinks to radius 0. You know what I mean? Okay. All right. So why is Mr. doing dragging you guys through all these equation of circles again, making you decide? So let me erase this one right here. One last one. What about this one? Is this a circle? Yeah? Tell me the information about this circle. Center. 0, 0. What's the radius? 1. Very good. This circle right here, ladies and gentlemen, very special. We refer to this only one right here. It's the unit circle. Right? The circle that's center at the origin, right? And then radius 1. So center at 0, 0. Radius 1. This is called the unit circle. See what I mean? Because on the unit circle, we're gonna make things easier to deal with. Because we're still talking about angles and rotation, but I want to introduce along the way. I want to blend in the understanding about the unit circle to make things convenient. So now here's a picture. X and Y system, right? And you can call. I mean, how big is a 1? Doesn't matter. Make it a scale, right? So how about I make the scale this big? Maybe I call it 1. See what I mean? Okay, so there's a 1 here. There's 1 there, right? There's 1, so your circle goes like this. See what I'm saying now? And I'm off scale all over, but that's your circle. Radius 1, right? You good with that then? Okay, so that's the picture, and that's the unit circle. So now I'm about to introduce for you a new convention, a new style of measuring, because so far measuring angles, we go with degrees and all that, right? One complete rotation goes 360 degrees. See what I'm saying now? But now we need to go even more than that, because degrees, and starting at this point right here, we will start to use interchangeably, okay? So be flexible that sometimes we go with degrees, sometimes we go with the new convention I'm about to introduce here. So you gotta agree with me. Now, one complete rotation, when you got a circle area like this, radius 1 and all that, right? One complete rotation will also equals to the circumference. That's it. Remember that term? Circumference of the circle, right? Do you agree with that logic with that? Because think about this, the circle in the end when you draw that, it has length, right? So if you straighten it down like that, right? That's how much it goes around a circle. Yeah, how it can cover around, we call it the circumference of the circle. So one complete rotation, right, is the circumference of the circle. So now I need anyone, I need you guys to remind me what's the formula for calculating circumference of a circle.
It's 2 pi r.
There you go. Circumference for C, right? C for circumference. 2 pi times r, right? That's circumference. But what do we agree about? So now specifically on this unit circle right here, then how big is the circumference? The circumference in our case right here specifically in the unit circle, right? 2 pi times 1. You guys following? Right? So on the unit circle, all of a sudden we realize, hey, circumference is 2 pi. Right? Circumference is 2 pi. So now we make another ultimate conclusion, a very ultimate conclusion. One complete rotation, we can also understand that as a 2 pi rotation, as a 2 pi opening up. See what I'm saying now? On the unit circle. Does that make sense? So one complete rotation is a 2 pi. So yes, this is the new convention right here, because ladies and gentlemen, you have to understand pi itself has a numerical value, right? A very nasty looking one. That's why we've always been keeping that as a pi to make it exact, but numerically it's a 3.14 analog longer, right? I mean, there was a book, and there is a book. It's still there now. Front page a 3 point. The rest of the book is all the decimal, non-stop. See what I mean? And then there's no point of keep making that book thicker, okay? It all depends on how advanced the computer is getting. But see, the point now is that it's a 3 point something, right? And then so 2 pi is 2 times of that, right? So 6.28 something like that. But we call this kind of unit right here the radians unit. That's another style, right? Another style of measuring angles, right? So one complete rotation, just earlier we called that as a 360 degrees rotation, right? So now one complete rotation, we learned that, hey, it's a 2 pi. Right? It's a 2 pi radians. That's what I mean, 2 pi in radians. That's how we're saying it properly. Anyway, it's not that like that. Okay. So, I have to erase the starting information right here. Now think about some further impacts. So everything I've been leading you guys through is still the same. An angle is a fraction of a complete rotation, right? So think about an angle that we used to know, like 180 degrees here. Okay? What fraction of a circle is this? What fraction of a complete rotation is it? Half, right? So half rotation. Okay? Does that make sense? It's a 2 pi radians, right? But cut it in half. You guys follow me? Yeah. So that's now what? So in radians, 180 is equal to pi in radians. Am I making sense? So it's a new style. Instead of calling that 180, right, we call it as a pi. Right? It's a pi angle in radians. Does that make sense? You guys keep thinking about that. So what about a quarter of a circle? When you go like a 90-degree angle here, quarter of a circle, right? 1/4 rotation. That means what? In radians now, one complete rotation is 2 pi, right? Now it's 1/4. Okay, you need that? Okay. And then the fraction cancels out. We got what? It's pi over 2. So yes, 90 degrees. Now in radians, we call it as a pi over 2 angle. Instead of a 90-degree angle, we call it as a pi over 2 angle. Good. Right? way we can have a few, see? So really, you gotta think about any angle. It doesn't matter if you go in degrees or you go in radians. The angle, the rule of thumb, the fundamental is it's a fraction of a complete rotation. Okay, so that can easily go interchangeably between the degrees convention or the radians convention. Yeah. So just like that, right? Then see, when you have a 30 degrees angle over here. See, a 30 degrees angle, right? Like that, the standard position. Just another prompt to trigger you guys, and then I'm gonna push that into one fundamental right here. But 30 degrees angle. What fraction of a circle is this? Had that there earlier, right? I mean, it's a fraction of it's a 1/12 fraction of a complete rotation. Right? So in that way, right here, a 30-degree angle is referred to as what? So 1/12 of a rotation, right? This is the same as a 1/12 rotation. And so a 1/12 of a rotation. Now one rotation is 2 pi, so 1/12 of that, right? Okay. That's gonna be what? A pi over 6. Cancel out the fraction away, right? So a pi over 6 is from now on, right? The radians convention, right? The radian style to indicate the 30 degrees angle. And of course, it's natural that way. We've been more comfortable with the positive rotation, but you will also have the negative pi over 6 angle, right? It's just about the rotation going in the opposite side, I mean, in the negative, in the clockwise rotation. See what I mean? So now in that way, let's go back to this understanding. So one complete rotation is a 2 pi radians. One complete rotation is a 360 degrees. But in that way, and we nailed that down earlier, half of that rotation is a pi, right? Or half of that rotation is 180 degrees. So we have this relationship. Don't you agree with me? 180 degrees in what we used to know, right? 180 degrees is the same as pi radians, or just pi radians, about 3.14 radians. You guys need that? That picture is still here. Still on this other board. A half rotation. A half rotation is on one hand, is 180 degrees, and then that just earlier we pointed that out. That's pi, right? Radians. And so that's why I made this fundamental understanding of that. That a 180 degrees will equal to pi radians. And so from that way, it's just if you think of this as an equation, you guys taking class with me, I want to train you guys in a way that it has the philosophy, the fundamental behind the scenes, so that you can always derive these things right here. So if you divide both sides by 180, then you bring yourself to what? 1 degree, right? Equals pi over 180 radians. You guys following? If you divide both sides by 180, right? Of that equation right there, then that means what? Dividing 180 degrees here, we got just 1 degree equals pi over 180, right? Radians. So we have this right here as a conversion unit. We use that as a, see, this formula now becomes vital for us we convert, right? It's converting from degrees to radians. See what I mean? Got a formula. And then in that same way, from that same fundamental, 180 degrees, right, is equivalent or is the same as a pi in radians, right? As a 3.14 radians. Then you can think about divide both sides by pi right here. And you're looking at 180 over pi. Right? 180 over pi degrees will equal 1 radian. Right? That's the formula just now derived right here. It's It's a formula that helps you converting, right? Converting from radians to degrees. All right. So now in that way, that's called an example 1 right here, where we apply directly our understanding here, and we see how we can use directly these conversion formula right here. So let's convert, right, from degrees to radians. And see, I'm showing some steps right here, because in case you guys are questioning me, then you see the steps how I'm doing it. But when it comes to these problems, it's easy enough that you can come up with your own way of getting the conversion done. But let's say if you got an angle that's measured, hey, 13 degrees, how do we convert this into radians? See what I mean? Right. So 13 degrees. So here's how I see it. We're going to go from degrees to radians, right? 1 degrees is a pi over 180. So 13 degrees. So 1 was pi over 180. So 13, you just multiply 13 to both sides. See what I mean? Right. So 13 degrees. Now 13 degrees will come out what? 13 pi over 180. That's the radians. See what I mean? So I started out. What did I do right there? I started out writing down that relationship between 1 will equals pi over 180. And then I need 13 degrees. I just multiply that 13 degrees to 1 to both sides, right? And that's how I arrive at the number of radians on the other side. And this is just my way of how it's natural for me. But you guys don't even have to follow that way. Okay? And then this is the exact expression. You can also use your calculator. Even your little cell phone calculator will do the job. Like 13 times 3.14 approximates, right? And divide by 180. And that gives you the actual decimals of the radians. See what I mean? It's not even the 1 radian, it's 0.226 something. Right? And a lot longer. But yes, that's the radian. 13 degrees is a 0.226 radians. Something like that. Or in exact expression, we call it as a 13 pi over 180. See what I mean? Okay. And so why don't you guys try this? So let's call that part A right there. Okay. And then you got to hang up that. You guys quickly try that. Part B right here. So how about an angle that's... And what about negative angle? When we're converting, then the sign is not too important. The sign is just to indicate the rotation. See what I'm saying? So what matters really is just, again, in the end, no matter which direction it is, 1 degree, right? So maybe still, let me lead the way here, but 1 degrees will go into a pi over 180. See what I mean? Okay? In radians. Okay. That's what we knew. So now I'm going to we want negative 100. So negative 120, right? I'm multiplying that to 1 right there. And then that will equal to negative 120. That I multiply with a pi over 180. See what I mean? Okay. And so that means what? The angle of negative 120 degrees will equal to whatever comes out from negative 120 pi over 180. And then that will reduce, the fraction here will reduce and becomes a negative angle. Okay? So it's a negative... after reducing that fraction. Right. And yes, we can also have another example converting the other way around. And we have 5 radians. Now, converting from radians to degrees, we have the other relationship, the other conversion formula. Right? 1 radian will come out to 180 over pi degrees. That's how Now we're starting out with 2.5 radians. All you do is just multiply both sides of this relationship, right, by a 2.5. So 2.5, and that's just my way of interpreting it. You can have another way of working on that as well. 2.5, right, multiply with 180 over pi. See what I mean? Okay. And then here, let's go ahead and say with all decimal values in there. So you guys go ahead and multiply it in 2.5 times the 180, right, divide by pi. Let's see what kind of final approximate you guys get. Round your answer to 2 decimal places. 143.24 degrees, right? About there, right? Perfect. See what I mean? Then some angles, you can also look at some angle in part B of the example. Say you got an angle over here, negative 7 pi over 12, right? In radians. We want to bring that into degrees. So again, 1 radian equals 180 over pi degrees, right? So we multiply that negative 7 pi over 12 to both sides. So negative 7 pi over 12, right? Times 1. That really equals negative 7 pi over 12, right, times 180 over pi. And this is some good thing. The pi got cancelled away algebraically, right, before we even have to use any of the decimals. And then now we have just what? Negative 7 times 180, right, reduced by 12 there. You guys got that still?
Negative 105.
Negative 105?
Yeah.
Okay. That's reach, right? Up. That's the term, it's just a terminology. You know. There's a term that people call angles being coterminal. Because the idea now is that you can go more than one rotation, right? 360 degrees or 2 pi is only one rotation. So now I'm just going to point out, and we don't need to formally give a definition. Think about there's an angle in standard position, 45 degrees, positive 45 degrees. Okay, so in that way, see, the terminal side is here, but you make one more complete rotation to hit there. Then think about it. So 45 degrees is the term here is said to be is what is coterminal. Right? It's coterminal with. I just said from 45 degrees, right? Another complete rotation from there. So what does that mean? 360 added on top of that. So 360 added to 45, what do we have here? Okay, that's going to be 405, right? There's another, see right here you go, another 300 degrees rotation. See what I mean? Okay, so 300. So that's right there. It's because it's 45, right? We plus 360 degrees rotation. Of that. So 45 degree is said to be coterminal. So those two angles, as far as the physical positions, right? They have the same terminal side. That's why it's called coterminal. You know what I mean? Okay. So, and that's not the only way, because now we're talking about going beyond one rotation, right? We can also go, hey, with 405 and with another 360, so it's 765, right? We add another 360 to that 405 right there. See what I mean? And then that's not the only way. What about the same angle right here? We can go clockwise in the negative direction. So it's coterminal with what? It's a 45 that we add to a negative 360, right? One complete rotation in the opposite, in the negative direction, right? From that angle. See what I'm saying? Huh? So the way we get coterminal angle is we always add either positive or negative number, right? But add either a 360 or a positive 360 or a negative 360, indicating a complete rotation, either positive or negative direction, added to that current angle. And so 45 plus a negative 360 is giving me what? Do the quick math with that. 315, yeah. See? So negative 315 is coterminal with that. We've got so many different angles that's coterminal with one specific angle. See what I mean?